Hello, and welcome to 5 Minute Math. Today we are looking at the geometric concept of reflections and translations, specifically how we can describe them using coordinate notation, and we'll do it in 5 minutes or less. So a reflection is a flip. It is a rigid transformation that mirrors a shape over a line of reflection. So let's look at the two most common lines of reflection. The first one is going to be over the x-axis. So if we were to look at this x-axis right here and we were to say, I want to reflect that triangle over the x-axis, we're going to flip it down. And using coordinate notation, what ends up happening is we take all of our x and y coordinates. Our x coordinates are going to stay the same. But what we're going to do is we're going to end up using the negative of the y coordinate. And so whatever our y coordinate is going to be negative. So here's an example. So my x values stayed the same, but my y values went from 4 to -4 to 8 to -8 and from 4 to -4. So my triangle XYZ became x prime, y prime, z prime because I reflected it or flipped it over the x-axis. Now, what happens if we reflect over the y-axis? Well, in that case, it's going to be the x value that's going to change. Our y value is going to stay the same, but we're going to have a negative x, and the y value is going to stay the same. So this is what that looks like. So now my line of reflection is my y-axis, and we're going to flip it over from quadrant 1 over to quadrant 2. Notice that instead of changing my y values, I'm now changing my x values to where they are the opposite. So my 2 switches to -2, right? My 8 switches over to -8, and then my 2 up here change over to -2. So we have our xyz now to x double prime, y double prime, z double prime. Now remember, these are rigid transformations, so they simply flip an object over a line of reflection. They don't rotate it, they don't resize it. So let's think about what happens when we translate or we slide an object. So a translation is a rigid transformation. Once again, it keeps the shape and the size here, but it moves every point in the figure in the same distance without rotating it or resizing it. So it's like you put your hand on the shape and you're just going to slide it up, down, left, or right. And so this is how we look at it. We think of our x coordinate and our y coordinate. And what we're going to do is we're simply going to add something to the a, and we're going to add something to the y. So let's call that a and b. Now, if our a term that's going to be added to our x is greater than 0, so we're going to add a positive number, what we end up doing is we end up moving it to the right. So if a is going to be greater than 0, we're going to slide it over to the right. It's going to increase on the x-axis. But if a is less than 0, so we're going to end up adding a negative, we're going to end up sliding it over to the left because we're going to decrease its x value. It's going to move to the left. The same thing happens with our b value, right? So if our b value is greater than 0, what we end up doing is we end up sliding it up because we're going to increase the y value. Whereas if the b is less than 0, we're going to end up sliding it down because we are decreasing the y value. Sometimes you just have an x value increase or decrease or a y value. Sometimes you end up getting both. So let's see what happens if we were to slide this object. We have a rectangle ABCD, and let's say we wanted to increase the x value by 5, but then we wanted to decrease the y value by 8. So what we want to do is we want to move this over 5, and then we want to move this down 8. So we would have a 5 and a -8. And that means that we would need to redraw this and have a prime, b prime, c prime, d prime with each x value increased by 5 and each y value decreased by 8. Let's take a look. So that's what we did here. We slid it over 5 and down 8. So let's just look at our a's, for example. So we had our a, we had a -7, but then we added 5 to that. And then we had our 6, but we subtracted a from that, and that ended up becoming a prime, which was -2, -2. And we see that right up here. We could do that for b, c, and d as well.